Today we are going to start class 11 chemistry chapter number 9 acid base chemistry and pH. Today our topic of discussion is pH and POH. First of all we see why the terms pH and POH were introduced. In all aqueous solutions, the concentration of hydrogen ions and hydroxide ion is extremely small. For example, in pure water at 25 degrees centigrade, the concentration of hydrogen ions is 1 times 10 to the power minus 7 mole per liter. Such small numbers are difficult to use in calculations and comparisons, so a very easy method was needed. Next we see what pH and POH mean. In 1909, a Danish biochemist named Suraj Sørensen introduced the terms pH and POH to solve this problem. Next we see what is the definition of pH. pH is defined as the negative logarithm of the hydrogen ion concentration. So pH is equal to negative log of hydrogen ion concentration. Now we see the definition of POH. POH is defined as the negative logarithm of the hydroxide ion concentration. So POH is equal to negative log of hydroxide ion concentration. Here the square brackets mean concentration in moles per liter. Now we see how to calculate pH and POH using examples. Let us take the example of pure water at 25 degrees centigrade. In pure water, concentration of hydrogen ion is equal to 1 times 10 to the power minus 7 mole per liter, and the concentration of hydroxide ion is equal to 1 times 10 to the power minus 7 mole per liter. Now using the formula P for pH, pH is equal to 7. Similarly, POH is equal to 7. So for neutral water, pH plus POH is equal to 7 plus 7 is equal to 14. This equation shows that the value of pH plus POH is equal to 14 is always true at 25 degrees centigrade for any aqueous solution. Next we see the pH scale. The pH scale generally ranges from 0 to 14 at 25 degrees centigrade. If the value of pH is less than 7, the solution is acidic, means it has more hydrogen ions. And if the value of pH is equal to 7, the solution is neutral, means it has equal hydrogen and hydroxide ion concentration. But if the value of pH is greater than 7, the solution is basic or alkaline, means it has more hydroxide ions. Also we see an interesting factor. Sometimes pH values can go below 0 or above 14. This happens in very concentrated strong acids or bases. For example, 1 molar hydrochloric acid has a pH of 0, means that it is a very strong acid, while 1 molar sodium hydroxide has a pH of 14, means it is a very strong base because the value of pH is greater than 7. In some cases, strong acids like 12 molar hydrochloric acid can have a pH of negative. Now we see a table of pH values for common substances. This table shows the approximate pH values of commonly found solutions. We can see from this table, since the table of hydrochloric acid is 0, so it is a strong acid. Similarly, the pH of the stomach acid is between 1.0 to 3.0, so it is also acidic. Lemon juice has a pH between 2.2 and 2.4, so it is also acidic. The pH of the carbonated water is 3.9, so it is a weak acid. Beer pH is between 4.0 to 4.5, so it is also weak acid. Milk pH is between 6.4 to 6.8, so it is slightly acidic. Blood pH is 7.4, so it is slightly basic. Seawater pH is between 7.0 to 8.3, so it is also slightly basic. Baking soda has a pH of 8.4. It is mildly basic. Milk of magnesia has a pH of 10.5, so it is basic. Household ammonia has a pH of 11.9, so it is a strongly basic, and pH of sodium hydroxide ion is 40, so it is strongly basic. Here we can see from this table, as the values of pH decreases below 7, it becomes more strong, and as the values of pH increases above from 7, it becomes a very strong base. Now we quickly summarize the overall lecture. pH tells us how acidic a solution is. POH tells us how basic a solution is. Both are calculated using negative log of the concentration. The sum of pH and POH is always 14 at 25 degrees centigrade. The pH scale ranges from 0 to 14 but can go behind this in special cases.